Hi, it's Wendy again, and this is the second video in our series about exception handling in Java. So as you probably already know, this is a three-part series, and in the first part I just did a review of what you learned in semester 1 about exception handling. In this video, we're going to talk about the different types of exceptions and how they're related to each other, and then this is going to help you better understand how to write better or more robust exception handling code, which is going to be what we're covering in our third video. So the main way we categorize exceptions, and this is probably the most important part of this entire series of videos, is checked exceptions versus unchecked exceptions. So what exactly does that mean? If we look at the exception class hierarchy, this is what you'll find. At the very top, we have the throwable class, and the throwable class models any object that can be thrown. Of course, that's going to include exceptions in there, but there's actually something else that can be thrown. One of the things that can be thrown is an instance of the error class. Now, you don't have to worry too much about the error class because you, as a programmer, have absolutely no control over errors. The error class models things that are thrown by the JVM, or Java Virtual Machine. These are things that you cannot recover from in your program. They include things like a Stack Overflow error. Yes, Stack Overflow is not just a website. They're actually named after a very common type of error called a Stack Overflow error. What the Stack Overflow error does is, as you know, there's this thing called the stack, and it's where you keep track of method calls. So if you're in a main and you call a method called method1, it's going to push an entry onto the stack that says, I was in the main at line number X, and then you finish method1, then it checks or pops that last entry off the stack and says, where did I come from? Where did I leave off? I was at line X in main. So that's how it knows where to return when it's finished executing a method. So that's called the stack. So a stack overflow generally can occur if you're calling a method repeatedly and your loop is endless. So you're basically calling the method endlessly, you are eventually going to fill up the stack with method calls. And so you'll get a stack overflow. So Stack Overflow error, that's part of the error class. It also includes things like class definition not found. So if you try to instantiate a class and it's not found, not that it's not imported, but that it's imported, but the class just, they can't find it anywhere. So that's a rare thing. It doesn't happen very often. It also could include out-of-memory errors. So if you run out of memory, this could happen if you're, say, in a loop instantiating several scanners and then you don't kill them off, you don't delete them from memory, you will eventually end up with an out-of-memory error. That's a really basic example. But these are things that you as a programmer have no control over when they happen. So we generally just hope they don't happen. We don't have to handle them. We just try to be good programmers and avoid them at all costs. Now, on the other side of this hierarchy, you have the exception class. The exception class is also a child of throwable, and it's the parent class of all exception types. So all exceptions in Java are either directly or indirectly descended from exception. In other words, every single exception in Java is either a child of exception or a grandchild, great-grandchild, etc., etc., etc. Sometimes if you want to create your own exception classes, which is actually not very difficult to do, and it's a really good idea, you can learn how to do that in chapter 12 of your textbook, you may decide to extend the exception class. It's a very common thing to do when you want to create your own exception object or your own exception class. So the exception class is the parent of so many exception classes, I couldn't list them all here. So I'm only going to list a few. One of them is really important. The other two I just chose because either you're familiar with it now or you will quickly become familiar with it in Java 3. So IO exception we've been working with because we've been working with file input and output. So IO exception is the parent of all the input and output exception classes like file not found exception, end of file exception, and other stuff. And then SQL exception, next semester in Java, you'll learn how to access SQL databases with Java code. And if you have, for example, an error in your query or some other kind of problem, you will get an SQL exception. So that's one that you might be familiar with in semester 3. I chose these two because they're very similar, and usually children of the exception class are dealing with accessing some kind of external resource like a file or a database server. If you get into the networking classes like sockets and URLs, all of their exceptions fall under this category as well because you're accessing external resources. So these kinds of exceptions, they generally affect your program's ability to do its job because you have an error or an exception accessing some kind of external resource and you're unable to. Now, one of the other children of the exception class is the runtime exception class. And you'll notice it's in blue. It's in the same color as the error class because these are kind of related, not physically related, but they're similar. The runtime exception class is different from all of the other exception classes that are a child of exception. Runtime exception and its children generally have to do with errors that occur from bad user inputs or bad programming, and you're actually not supposed to try catch anything that is a runtime exception or a child of runtime exception, because these are things you should be able to avoid with code. They include things like, and again, there's so many, I couldn't fit them all on the screen. There's a few more examples, by the way, in my notes. So these include things like null pointer exception. That's the exception that occurs when you try to invoke a method on an object variable that contains null. You'll get a null pointer exception. We've talked about this several times this semester. Number format exception. That's an exception that's thrown from methods like parseInt or parseDouble, and it occurs when you try to pass in a value that cannot be parsed. For example, if you pass a decimal value into parseInt, it'll throw a number format exception. If you pass a string, like some characters, into parseInt or parseDouble, they'll throw number format exception. And then, believe it or not, illegal argument exception is in fact a runtime exception. Now you might be thinking, hang on a second, if illegal argument exception is a child of runtime exception, and we're not supposed to try catch runtime exceptions, why have we been using a try catch with illegal argument exception? So there's two reasons. One, because you learned it in semester 1, when getting into the difference between checked and unchecked exceptions was just not appropriate. Not because it was too hard or anything, but you weren't going to get to use any checked exceptions, any of the stuff like IO exception, until semester 2. So there's no point in talking about it. And then the other reason is because it made it easier for us to show you how to use a try catch. We didn't want to wait until semester 2 to show you how to use a try catch. So we did kind of do that incorrectly, but also, and if I can add a third reason, illegal argument exception is the exception to that rule. If you have to make one, I guess this is it. There are people that will argue with that, and they would be perfectly legitimate by saying, no, you should never try catch illegal argument exception. That's fine. Again, we taught you to do it in semester 1 because we kind of had to, but generally, you shouldn't have to. I will show you some tricks later to if you want to say, well, yeah, but I need to throw illegal argument exception. I'm not supposed to try catch it. What am I supposed to do? There are actually some alternatives that we'll talk about. So the difference then, and you'll notice I've got some of these classes in blue and some of these classes in a kind of green. These classes over here in green are what we call checked exceptions. So anything that is a child of, we usually would say a child of exception, although throwable is checked as well. But anything that's a child of exception, except for runtime exception, is a checked exception. Anything that is either in error, so the error class or any of its children, which we don't really care about anyway, or anything that is a runtime exception or a child of runtime exception are what we call unchecked exceptions. So what does that mean? Why are these checked exceptions and why are these unchecked exceptions? The reason why is because when we talk about checked exceptions are checked by the compiler. That means if you write a piece of code that may or may not throw a checked exception, you will get a compile error. So here's an example where I've got a method called connect to file, and I'm instantiating a scanner and giving it a file object. We know from our past experience that that could possibly throw, I believe it's a file not found exception, which is a child of IO exception, which we just saw is a direct child of exception, so that means it's a checked exception. So the compiler checked and noticed that it is possible. It's not saying it's going to happen, but it says it's possible that this method might throw an exception. If you were to hover over that error, you would see this tooltip. It says unreported exception, file not found exception, which as we know is a child of IO exception, which is a checked exception because it's a direct child of the exception class, must be caught or declared to be thrown. That's the key thing. Must be caught or declared. This is outlining your two possible solutions to getting rid of this compile error. It's saying you must either catch this, i.e. use a try catch block, or you must declare it, i.e. use a throws in the method header. So two possible solutions. I can catch the exception. So I can enclose the statement that might throw the exception in a try block and then add a catch block to deal with it. Alternatively, I could add the throws clause to my method. What that will do, this is called declaring the exception, as we saw earlier. What that will do is if the exception does occur, it will throw it out of this method up to the calling statement. So let's say, for example, I have a main method. I'm just going to do this because I don't have a lot of room. And then in that main, I was calling the connect to file. So since this method declares that it throws a file not found exception, that exception will come out of connect to file and land here in the main method, which means I would have to, in the main, I would have to add a try catch block in here. So I would have to add a try catch block in the calling program where that exception was being thrown to. So when you declare an exception, what you're saying is that you want the exception object that's thrown to come out of this method and land in the calling program. In this case, in my example, the calling program is main. So it's in the main where I would have to add the try catch. Or you could add the throws clause up here if you wanted to. You could add the throws clause to the main method header. That's acceptable in some instances. So that's what they mean when they say it must be caught or declared in order to be thrown. Generally, when you declare an exception, you have to eventually catch it somewhere, right? It's got to end up someplace. You can't just let it go, right? Like the song, let it go. You actually have to handle it somehow, eventually, even if it's far up the call stack. We'll talk more about this when we talk about event propagation. Now, unchecked exceptions are different. The compiler doesn't check for unchecked exceptions. So if I have this method called do some things and I've got a couple of parameters, and this isn't a very practical example at all, I just threw in some random code that I thought might throw some exceptions. So let's say, for example, the user passed in, by user I mean programmer. So the other programmer that's using our method passes in 1, 2, 3 ABC for value and then the number 7 for index. And so in my first line of code, string str, I'm using substring, which starts at position 0 and goes up to index, which right now is value 7. And it will grab that string and return it. Now the problem here is that if I go from 0 to 7, the length of this string is 6 characters. It indexes only go from 0 to 5. So that means the index 7 is going to be an index out of bounds. It's more specifically a string index out of bounds exception. So that line of code, the substring method specifically, could throw a string index out of bounds exception. Similarly, when I take value 1, 2, 3 ABC and try to pass it to parseInt isn't going to like the ABC. So parseInt will throw a number format exception. Now, only one of these exceptions can be thrown at a time. If these were the actual parameter values, then it's going to throw string index out of bounds, and that's it. It's not going to throw both. It'll only throw one at a time. I'm pretty sure you knew that. So the problem here is that if I passed in valid values here, no problem at all. If I pass in invalid values, I'm going to get an exception, either string index out of bounds or number format exception. Why am I not getting compile errors like I did when I used scanner with a file object? That's because the compiler doesn't check for these exceptions. In the earlier example, if I could just back up here for a second, in this earlier example, it's actually showing it as a compile error because the compiler checked and said, hey, this might throw an exception. You need to do something about it. Whereas here, it's not showing a compile error, and that's because these are unchecked exceptions. The compiler doesn't check to see if they might occur and doesn't expect you to handle them. You are not required to handle unchecked exceptions, but you are required to handle checked exceptions. So with unchecked exceptions, what you're really supposed to do, you're not supposed to use a try-catch. The reason why is because try-catch blocks are not very efficient. They require a lot of resources. They're very resource heavy. With checked exceptions affect the user's experience. They affect the program's ability to do its job. And it's generally things that it's not that you don't have control over these things, it's that you have less control over these things. Again, checked exceptions, they generally deal with accessing external resources. So if you have an application that relies on a file or a network connection, the user can't really have the experience you intend them to have if they can't access those resources. Whereas unchecked exceptions, these occur because either the user has input something that's invalid or the programmer has not written robust code. They haven't done proper error handling, and both sometimes. So you're not supposed to waste overhead of a try-catch block on an unchecked exception. You're supposed to write code to avoid unchecked exceptions. So in this example, what I should do is I should check that the index is valid before I use it. So if the index is not valid, I just chose to return 0. Again, this isn't a practical example. I just kind of made this crap up. I was coming up with something to do. So I just returned 0. You could do something else. I chose to return 0. And then similarly, before you parse int, parse double, you should maybe do a regex is the easiest. And that's why I've said over and over throughout the semester, take the time to learn regex. I know it's annoying because nobody's teaching it to you directly. I'm trying to change that, and it doesn't affect you at all, unfortunately. But you did have access to that really awesome regex tutorial that was really easy to use. So try to use things like regex and if statements to check and see that something matches a pattern before you try to parse it. If it doesn't match, that means parsing is going to crash the program with the number format exception. So then you don't parse it, you do something else. Again, here I chose to return a 0. This is also why we do things like check to see if a string is null first and then check to see if it's empty, because we don't want to crash with the null pointer exception. It's your responsibility as a programmer to ensure that you avoid unchecked exceptions in the first place. You should never be handling them with a try-catch block. Another quick thing that's worth mentioning here before we get into an exercise is that you should never shut down a program because of an exception unless it's something so severe that the program can't recover. And even in that case, it should only happen during startup. You don't want to have a program where the user's using it, maybe they're entering data and saving it to a file, and then suddenly the program shuts down because of an exception. That's going to suck for the user. They're going to hate you when you do that, because then they've just lost everything they've been working on. What you should do instead is inform the user that something really bad has happened, and if possible, give them a way to fix it. If it's, again, usually these checked exceptions deal with accessing resources. So if it's a file, give them a chance to try looking for a different file. In JavaFX, for example, there's a file chooser dialog. You can pop that thing up and let the user browse around on the computer and choose the correct file. Or if it's a network connection, you can have a sort of retry, try again. And then even when you get to a point where it's like, look, I can't solve this problem, let the user choose to say, okay, I can't really do this now, so I'm going to exit. Let the user choose to exit the program. Don't just shut down on them, because that's just going to piss them off, if I can swear. If you really do have to shut down and say, look, I can't do this, You know, we all wake up with days like that. I can't do this today. But if you have a situation like that in your application, do it when the program starts up. So you start up and you're like, no, I can't. And then you shut down. Make sure you have some way of telling the user first, maybe pop up a dialogue saying, I'm going to shut down because of this. You need to contact program support and tell them XYZ. Let them write that down, and then they click OK, and then the program shuts down. Don't just shut down a program because of an exception and not tell the user why, and definitely don't do it while the program is running. If you have to, do it during startup. Okay, let's do a really quick exercise. This exercise, you need to open up the API documentation for Java. So I'm going to give you a set of exception classes. I want you to look each one up in the API documentation, and I want you to identify each exception, whether it's a checked exception or an unchecked exception. If you go back or use the notes and look at the hierarchy of classes, I pointed out how you know which exceptions are checked and which exceptions are unchecked. So you can find this information that you're looking for in the API. So if we look at these, I think there's 6 exception classes. Go ahead and pause the video and then look each one up and make a note, or tell your cat, your dog, somebody who's in the room with you, talk to the wall, talk to the TV, whatever, and identify which one of these exceptions are checked and which are unchecked. When you're done, come back and I'll show you the answer. Okay, so hopefully you've had a chance to look up each one of these. The key way to find out, by the way, is to simply go to the API documentation and look for the exception. So you just go into search. I think the first one was print exception. So you type that in and you look under types, and there it is. There's just one. Printer is different. So you look up print exception, you click it. You've seen me do this before, and you look and see it says its parent is the exception class. So that's how you know that's a checked exception. If you look up illegal argument exception and look at that one, you'll see it's a child of runtime exception, which is a child of exception. Remember, anything that's a child of runtime exception is an unchecked exception. So that's how you know it's an unchecked exception. So the answer, there we go. So print exception, file not found exception, and parse exception are checked exceptions, so you would be required to catch or declare them in your program. And then date time exception, illegal argument exception, and input mismatch exception are all unchecked exceptions. You should avoid these using code and not with a try-catch block. So now that we have a better idea as to the difference between checked and unchecked exceptions, this is going to help you write better exception handling code. So that's what we're going to do in the next video with a couple of coding demos. I'll see you over there. Thanks for watching.